This is the difference between beginner front-end developer and someone companies actually want to hire. And most developers never learn this because tutorials don't teach it properly. So whether you are a beginner or a senior experienced developer, in the next 7 minutes, I will explain the 7 front-end system design concepts that make your apps faster, scalable, and production ready. And concepts number 5 is the one most developers completely miss, so keep watching. Every scalable front-end application starts with one thing, a clean folder structure. Without structure, your app becomes impossible to scale and harder to maintain. Professional developers organize code by responsibilities, components for UI, hooks for logic, and APIs and for data fetching. This makes your application scalable and production ready. Second concept, which is component architecture, is the practice of building your interface using small, reusable, and independent pieces instead of one large file. For example, your navbar, buttons, and product cards should each be their own components. This makes your application easier to maintain, easier to scale, and faster to develop because you can reuse components across multiple pages without rewriting code. It also makes your code base cleaner and more organized, which is essential as your application grows. But once your app is split into multiple components, a new question appears. How do these components share and manage data? That's where state management comes in. State management is the brain of your front-end application. It controls how your app reacts to user actions. Professionals centralize and use state management to reduce the number of requests made from the front end to the back end by caching the data on the client side. So in traditional applications, maybe we have a client which sends a GET request to a server to get a list of training data. And let's say if the client decides to delete a training or updating a new records, so it's going to send an update operation to the server. Then it maybe also send a follow-up request to get a new list of training data. Then you can use here we are sending a lot of repetitive GET requests to get the training data, which is we can simply just cache that data from our client side, and that's why we can be able to use state management to reduce the number of calls. And what we can is we are be able to save the data inside of our state management, and whenever the client is going to render this data, we can be able to use this data from the cache, and the cache data is coming from the response from the server, right? So for example, at first we may have like empty list for the trainings, and then when the client sends a request to get a list of trainings from the server, then the server is going to return us the data. And here you can see we are using the interceptor. So every time when we send a request, we are going to attach with GWT tokens and headers to authenticate our service in the server. And every time when we get a response from the server, we can be able to intercept it, and we can be able also to take the response and save it in our cache. So the client can basically just read it off the cache data, right? And the data from our local storage or state management. So in this case, every time we make a delete operation, after we delete it, we simply just modify what we have inside of our cache. So in this case, we use the 3 objects, but now we only have 2, and we don't have to send another GET request to get server to get list of new trainings data that we have, because we already have these things. Right now, obviously the data may not be in sync, right? But could be a situation where we are deleting a request, but on the other side of the word, maybe someone is also adding a new records, right? So maybe the data here is maybe still. So in this case, how to decide we are going to keep our data up to date, right? Maybe by setting up expirations on our cache. So maybe after a certain period of time, we are going to refresh the data. So maybe that's something that we can decide. But all in all, you can see by using state management, we can reduce the number of calls being made from the client to the server. Now, speaking of setting expirations on data coming from the API, we can also use the use query from the React query library. So to basically make our API calls, like for example, here we have use queries. We are basically
calling the fetch data to fetch the data that we need. And here we can see once we have the data, we can be able to consume it. It renders the data in our client application. But we can also set in a still time, which is in expiration when we are going to make another call to the API. So for example, this is our user interface, and then when we send a query, we are going to see if it's a valid in a cache. If the data has not been expired, then we can be able to return the data that we have already fetched. If not, we are going to retrigger another call. Then yes, we can be able to return the data that we have already fetched. If not, we are going to trigger another call. Then once the data is being returned, then we can be able to store this inside of our cache. So you can see this process. It also makes it easier to reduce the number of requests, and also it's going to make the API settings and expiration time for data to keep our data. The next decision is where your app should render the data on the server or in the browser. So our application has 5 different strategies that we can use to render the content. And the first one, we have the static site generation, which is pre-build the page at build time, which has the fastest performance to load the page on the client. Then we have also the incremental static regeneration, which is updates the static page on demand without a full rebuild. Then we have also the server-side rendering, which generates the page on each request, which is the more suitable for dynamic content. We also have the client-side rendering, which loads a blank page of HTML first, then fetches data and compiles the JavaScript code on the client side. And lastly, we have the partial pre-rendering, which is it makes the pre-rendering and dynamic content on the page. This last concept, which is performance monetization plus lazy loading, is one of the most front-end concept system design that developers miss. Let's talk how actually we can measure and optimize our rendering performance, because if our application is slow, then users won't wait around. And before we optimize anything, we need to find out what slows things down. We can use a Chrome DevTool performance tab, and this lets you track the first contentful pane and time to the interactive. Basically, how long it takes before users see or interact with our application. And also we can be able to use React DevTools profiler to show which components and which renders too often and where the slow parts of our application. And then we can use the Datados and Lighthouse and Overpage test to give detailed breakdowns of the rendering performance across different devices and network space and browsers. And once we find the problem around that we can prove, then we can be able to fix them. And one of the biggest performance killer is unnecessary component re-renders. So in React, as you know, if the parent components renders, all of the children renders too. So the way how we fix it, we can be able to use memoization hooks. We can be able to memoize the component. For example, we can use React Memo, where we can be able to memoize the components. So it will be only renders if the props change. And we can also use the callback, which is memoize the functions to prevent the unnecessary function recreations. That we can also use the memo to cache the expensive calculation of the function to avoid recompute them on every renders. And we can also use Chrome DevTools and React Profiler to visually see which components are causing unnecessary renders. And of course, if our application loads too many components once, then users have to wait longer before they can see anything display on their application, which could be a frustration on the consumer side. So the solution to this, we can use the lazy loading. So instead of loading everything up front, we can choose to load components when the user needs them. So for example, let's say we have a dashboard, which a chart and analytics. So instead of loading everything all in once, we can lazy load the charts and analytics if user click on it. So now the charts and the analytics won't load until they need it, which will reduce the initial bundle size and make the application feel much faster. So then once we prevent the unnecessary renders and lazy load components, there is some extra things that we can be able to improve.
the performance things like reduce the JavaScript bundle size using the tree shaking to remove the unused code, and split bundles for faster page loads. Or we can also use skeletons, screens, or spinners or notification to make our application more responsive. And we can also optimize the mobile size also, and also we can add the accessibilities to make sure that our application works well for all the users. Screens, small screens or bigger screens. All right, so once we have improved the performance on the client side, now we understand the core front-end system design concepts that make modern applications scalable, fast, and maintainable. From organizing your folder structure to managing state, choosing the right rendering strategy, designing efficient APIs, using caching, and optimizing performance with memoization and lazy loading. These are the same principles used in real production apps. If you focus on applying every few of these concepts in your own projects, you will already be ahead of most developers. And if you found this helpful, subscribe and follow my journey as I share more real-world web development lessons. See ya in the next video.